Hello and welcome to the April 2020 RCA discussion and webinar. Tonight we'll be discussing RCA modeling. This is the second part. However, I will do a brief review of basic RCA modeling for those of you who may have missed that session. What we'll do today is we'll get a real overview of the structure and the information content of an RCA model by looking at an example. Now, this is going to be very fast, and I understand that. And if you would like some more explanation or discussion, you can bring it up in discussion, or we can set up a time to go over it in more detail later. Also, just to let you know, I am recording the presentation part of this webinar. When we start the discussion, I will unmute you and I will turn off the recording so that your questions or comments won't be saved for posterity. All right, first of all, resource consumption accounting gets its main components from German management accounting methods known as GPK, or Grenzplan Kosten Rechnen, as well as some of the process views of activity-based costing. You may not know much about GPK and German management accounting, but it's been around since the late 40s. It's used extensively by German firms, and that's been verified through research done by the Institute of Management Accountants some years ago when we first discovered this. RCA focuses on internal management decisions, enterprise optimization, capacity management, marginal and incremental analytics, and creating a model that gives you a cause and effect linkage, and that lines up operations with the monetary view. It's generally not used for regulatory cost accounting because the information it provides is in a different format and frankly much more detailed than what's required for regulatory financial reporting. Some years ago, the International Federation of Accountants, Professional Accountants and Business Committee looked at costing approaches. They came up with this table that shows resource consumption accounting was considered the most sophisticated costing method available. It was at the time defined as just short of real-time simulation. I would argue, and there are some examples now where real-time simulation is almost being done, and it's using primarily RCA methods. So that just gives you a sense of all the range of costing methods that are out there, from traditional standard costing, activity-based costing, and then RCA. RCA uses the IMA, the Institute of Management Accountants, conceptual framework for managerial costing. The principles of that framework are causality and analogy. The goal of causality and modeling is to create an operational model that is then costed. And that forms your baseline optimization information. Now, this is very different than what we typically think of in financial modeling, where you model the dollars. In this case, in RCA and according to the conceptual framework, the idea is that the dollars follow the operational quantities. The conceptual framework for managerial costing has a number of concepts and constraints that are incorporated and defined in that framework, and RCA uses these concepts and acknowledges the constraints when building its models. Excuse me. A brief review. Now I'm starting to review what was presented last month. So this kind of hopefully mildly attractive diagram kind of represents the information content of an organization. If you look towards the bottom of the page, you see that there's a fair amount of structure to the colored blocks down there. And that's typically what you find in the operations area. Things are very well organized, and the cost and resource flows are well understood. Up at the top, you see kind of the administrative and support areas of the organization. There, the relationships, the causal factors, the flow of resources is typically less well defined. So the first step in RCA is always to identify the resource pools and their outputs and the causal relationships. Now, no resource pool has a single causal relationships. Many times those causal relationships, particularly among support and administrative, are reciprocal. And we'll show you a little bit about how RCA models those. Again, I'm going through this very quickly because I did the session slowly last month. The key is to divide the organization into resource pools that basically create a homogeneous output. And that's what we're showing here. The next step, once you do that, is to identify the characteristics of each of the resources in that resource pool. And the way you identify them is that those resources either have a fixed or a proportional relationship, very rarely an inverse relationship, to the output that's produced. So in this diagram, we're representing the fixed relationship with a solid line and the proportional, or what you may think of as variable, relationship with a dotted line. And what you do is you look at all those relationships, you look at them first operationally and then with money, because the modeling of the operations is literally the same as the modeling of the money, except operational relationships are not necessarily always in the same unit. That's the value of modeling financially. We call that the primary consumption relationship, the resources inside a resource pool to that resource pool's direct output. And we might summarize it like this, where there's all those resources in the resource pool transmit a fixed quantity and a proportional quantity in the associated dollars to the resource pools that use that. And it may not just be one, it may be several. Now there's another relationship though that we need to explore, because remember this diagram? First of all, there's not just one arrow out of each resource pool. There may be reciprocal support relationships. So this resource pool is probably, and most are, supported by another resource pool. And so, the fixed and proportional relationships from those resource pools come into the resource pool you're looking at, and then they need to be evaluated for their relationship to the output of the resource pool you're currently modeling. And then we simply summarize the picture with one arrow, not necessarily different sizes like you see these. That's my bad slide making, but with one arrow. And the understanding is that every arrow typically involves both fixed and proportional set of relationships. Now, let's look at an example, because that's all very theoretical. Hopefully this will make a little bit more sense. So here we have something we'll call the get well plant. And we're going to look at a model just of the production facilities. We could extend this, but I'm trying to, for a little bit of simplicity in what's a very complicated process. So what this Get Well plant does is it produces 4 pills, millions of some, hundreds of thousands of others. It doesn't really matter right now, since I want to focus on the modeling and the information RCA produces about the facility and give you a sense of how the modeling is done. So we've divided the Get Well plant into 3 resource pools. The first one is production line 1. And production line 1 is the older production line. It produces just 2 of the products. And then we have production line 2, which produces all 4, is capable of producing all 4 of the products. So we've separated those 2 because they have different capabilities. And that's an important evaluation point when you do RCA modeling. How do you define a resource pool? You could put line 1 and line 2 into one big resource pool, but in this case, it was felt because of the company's need to understand that you needed 2 resource pools because they had very different capabilities. Now, the packaging is the same capability, so we put both of the packaging lines into one, because really physically in this one the distance isn't very far, and if for some reason line 2 is producing enough to engage both packaging lines, that can happen if line 1 isn't operating or is operating at a very low pace. Okay, and then we have support resources. So in this case, we have utilities and facilities for square feet, utilities and facilities for kilowatt hours or electricity, system support, maintenance, and maintenance on the equipment. And then we have a downstream resource pool of distribution. Now you can see on all of these, what's been identified is a primary quantity that comes out of those, and I didn't include it in here, but you would also be identifying the quantities of the resources inside that pool. So, there's a couple of questions that have been raised here. How do we build an RCA model? I'm going to show you a little bit more about that. What about the level of aggregation? Well, I've kind of addressed that. You could be more detailed than we are here, but you have to draw what's reasonable for the kinds of decisions you're going to make in your organization. So let's look at what happens next. So I just want to remind you what we have here is line 1. Remember, we talked about line 1, and it has production 1 is the resource pool, and we divided it into 2 sub-resource pools. So actually we think of line 1 as a cost center, and then we have 2 resource pools in it. So first is production, which is the labor hours, and second is production, which is the machine hours. Now you might ask, why did you divide those 2? Well, machines that you own are available to you 24 hours a day, 365 days a year. Production labor is typically only available in 8-hour blocks, and even if you run more shifts, there may be shift differentials, which, depending on how important and how significant that is to you, may merit several labor pools. Again, this is where you get into a little bit of the art, not just the science here, about how much information you need to make decisions that are important to your company. And then we show all of the support resource pools and their relationship to the various to the 2 resource pools within the cost center of line 1. Okay, we do the same thing for line 2. Again, labor, machine hours, and then the relationships to the various support pools are mapped. The arrows are there bringing in the fixed and proportional relationships. We look at packaging, and in packaging, again, since it's made up of machines and labor, we divided that up. And of course, we had to look at the relationships of the support resource pools to that. And then we have all of the support resource pools, and you can see that they do in fact have reciprocal relationships, because in addition to supporting the production resource pools, they also to some extent support each other and the distribution resource pool. Now, this is what we had before. This is just a repeat without all the colors. You have to solve this using matrix algebra, and what you get is the primary and the secondary relationships that line one, production line one, is putting forward into the various products it produces. Okay, and you can see that we have it broken down: primary, secondary for labor, then fixed and variable that would be supported by quantities, and you develop a rate for each of these as well. Okay, nothing too magical. Here's line two, the way it was seen before, and then we do the matrix algebra and we come up with this. The primary and the secondary, same thing. Packaging, you saw this before, and then we solve it to come up with the primary and secondary relationships. And of course, you saw this slide before for the support. We solve it and we come up with the solution for the primary and support, both the fixed and the primary, which gives a total package of what they move forward into the resource pools they support, or in the case of distribution, they primarily support products. Now, let's take a look at what one of these things means and how we use it. So this is, we'll use maintenance as the example here. So this is the solution for maintenance. And you can see, so the question is, should you outsource maintenance for $30 an hour? And let's look. The first place we want to look is we want to look at the rate. Well, the rate, the total rate is $33.04. So that would tend to say, yeah, we might want to outsource maintenance. We look a little further, we see that the proportional or variable rate is $22.56. That says, no, we don't want to. And we find out that the rate involves $10.48 worth of fixed costs. Now, this isn't a completely cut and dried result here, okay? What you'd use this for is you want to go back through this, use it as a checklist, because what you have to check, you know you can save the proportional amounts because they're pure. They don't have any fixed dollars in them or any random allocations. What you have to do is you have to look at this fixed rate and say, if I outsource maintenance, will any of these things actually drop off? So the fixed salary dollars here might be the supervisor. We actually typically think of a supervisor as fixed, okay? Will that supervisor disappear if you outsource maintenance? That depends. Maybe you'll need a contract manager for the maintenance contract. I don't know, but it's a question. You know, will the fringe benefits that you've included change? as fixed. The supplies may change. Will the equipment go away? Will the depreciation change? Is there another use for the square footage? Another value added use for the square footage, not just doesn't become idle? Or will the maintenance people that you contract to have to use that? Will the electricity change? Will there be a change in the system's support based on this change? All of those are questions that need to be answered, but they're very clear here for you to go back and take a look at and say, will these things change? Well, I hope I've given you some sense of how RCA works and how RCA modeling is done at a much more granular level than I did last month. So what I'm going to do now is I'm going to first